All right, good morning, geometry guys. Coming at you from my third period class. Don't forget, hit like, subscribe at the bell. As apparently there's some type of long snapping of somebody's beanie from across the room. All right, so this is kind of a review right here from yesterday's practice and Monday's lesson. Okay, two polygons are similar if corresponding angles are congruent and if their corresponding sides are proportional. Okay, so we are going to use this as our basis for today's lesson. Now, all right, so we have this thing right here that's called it's the person again who was in charge of this. What, that was supposed to be a highlighter. No, there we go. All right, angle, triangle, similarity, postulate. Okay, so this is what we're going to do. We're going to shorten that because that is a lot. We're going to say that this is the, oh wow, what happened there too? We're just everywhere today. All right, so angle, triangle, similarity. All right, that's how we're going to shorten this. All right, because there's really no reason, unless you just really want to write angle, triangle, similarity, postulate. Okay, so we have to look at this. It says if two angles in one triangle are congruent to two angles in another triangle, then they're similar. All right, well, let's look at this. We know that this angle is congruent to this angle. Are there any other angles that would be congruent to each other? G, why? Yeah. These are vertical angles. Okay. So we can say, we know that angle T is congruent to angle R. We know that angle G is congruent to angle G. Okay. Could be reflexive. It could be vertical angles, but basically that. So now it says, is it similar? So we're going to say yes. So this is triangle TIG is similar to triangle REG by angle, triangle, similarity. Okay, so and the reason why I'm writing that somehow, like, well, it's when we actually have 3 practice problems today that a lot of people, yes, I know it's Wednesday that we started, our first day back from a 2-week break on a Monday, and everybody is pretty much exhausted. Okay, so but we'll have stuff on this later. All right, has everybody got this written down? And as we're going over this, I'm already planning what your practice stuff is going to look like, so it will make things a little bit easier on this. Okay, like I might have a word bank where you just use like A, B, or C, because at least you're going to see it over and over and over again. All right, so example 2. Side, angle, side. Okay, so shorthand for this. Forgot a dash. All right, side, angle, side, triangle, similarity. Okay, we're going to use dashes in between these other than putting them all together, because some people get carried away and some of y'all's handwriting is horrible. Good thing about 80% of the stuff that you do in the world is typed out. Okay. All right. So we're kind of looking at like this has got to have a sandwich. Okay. And this is why. We have this side, we have this angle, and we have this side. This side, this angle, and this side. Okay. And you know, if you have a sandwich, it's called by what's in the middle. Okay. If I have a bologna sandwich, it's not called a bologna sandwich because bologna's on the outside. All right. So, are the triangles similar? Well, we know that angle C is congruent to angle M because they're right angles. Okay. Now, we need to check to see if the sides are in proportion. So, let's do RC over SM. Well, this is 6 over 8 which reduces down to 3 over 4. Alright, so as long as this other side, this little short sides on both of them are in proportion to 3 over 4, we're going to be similar. Okay? So, let's see. We'll do IC because I like a good IC. And then OM. Alright. So, it is 3 over 4. So, triangle RCI similar to triangle SMO by side, angle, side, triangle similarity. Okay? So, and the reason why we're having us do the triangle similarity is because there's a side angle side for congruent triangles, and you don't want to, you know, those can be confused. Okay? Alright. Yeah, really heavy on note taking today, more than calculations. Okay? This is one of those big vocabulary things. See, this is why I like geometry, is because it had vocabulary. Like, if it was this, it was this. That was it. There was no, but maybe if, nope. Okay. Alright. So that was example 2. Alright, 3. Side, side, side. This is a Snake's favorite theorem. You like that joke? Or somebody passing methane gas from their underleg? Alright. So, side, 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 triangle similarity. Alright. So, we need to look. See, now, here's the bad thing about this. Okay? Unfortunately, a lot of our things I didn't really look at it that deep because I was excited. I was like, wow, it's 2:30. I've already got both handouts made and printed, and I don't have to do work at home, and I forgot to really look over this very well to see if anything. A lot of this stuff is kind of wonky. This one actually goes with this. Okay, so we're going to look at this. We're going to say AB over EF alright, well, 18 over 24. Alright, this is 3 over 4. So we need all these other ones to reduce down to 3 over 4. Alright, so we're going to say BC and FD. So that's 12 over 16. which is 3 over 4. All right, so right now it's looking pretty good. And AC over ED is 15 over 20. All right, so that's 3 over 4. All right, so all of our sides are, that's not where that goes. Yep, there we go. All right, so all of our sides are in proportion. So triangle ABC similar to triangle EFD by side, 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 triangle. Okay. All right, we good here? Yeah, I know it's a lot of writing today. All right, just a few more people. Yep. All right. Is that the last one? Okay, good. All right, so example 4. So now we have those 3 things. We have angle, angle. We have side, angle, side, and side, side, side. Ways to prove that these are similar. All right, so let's look at this one. We have this angle and this angle. Okay, those are congruent. So we have one congruent angle. We have 2 congruent angles. All right, so these are congruent by the angle, triangle similarity. Okay, that's really all you have to say. Since we have 2 congruent angles in both of them, good. Now it says to find x. Here's where, when they're not set up in the same orientation, that can be bad. All right, so let's look over here at this 6 centimeter. It's between the 1 arc and the 2 arc. The only other measurement between the 1 and the 2 is x. So it's going to be 6 over x. And then the other one has to be 8 over 12. All right, that's one of those using context clues things. Or stating the obvious. Now, I don't know if any of y'all, as teenagers, are really good at stating the obvious. Like when somebody comes in after the bell. I bet nobody in here says, like, you're late or something, right? No? Nobody in here? Okay. I figured. All right. So, AX equals 72. All right. So, X equals 9 centimeters. Okay. Now, we're actually doing, like, beforehand when we were writing stuff down, that's a loose way of doing a proof. It's just stating all the facts, okay? Anybody like some of these law shows where you have attorneys that have to have, like, this, and this? Okay, that's basically all we're doing. All right. was supposed to move. Alright, so next two things. Hundreds of years, similar triangles have been used to indirectly measure height of tall objects. They're hard to measure by shadows and mirrors. Yes, this is actually still used today. Okay, I know some of y'all be like, well, why don't they just use their phone? Well, not everybody has one all the time. Okay, shadows and mirrors. Now, alright, so here's our shadow thing right here. This makes a triangle, and this makes a triangle. Alright, so this would actually be, the reason I can do this, this is actually by the side angle side. Okay. Alright. So if we set it up like this, our 6 foot tall person is should be proportional to this. So this would be 6 over x and then 5 over 25. Alright. Now, just like we did yesterday, we cross multiply. So this would be 150. This would be 5x. And then we divide. So x equals 30 feet. Okay. So the Fallout Boy thing where y'all, you know, you would hold your thumb out. Y'all have seen that on like the video game and stuff. This is actually the same thing. Okay, how to tell your distance away. They just applied it for, like, you know, explosions. So and the last one, this one's using a mirror. So these two, and then so we can actually do this by angle, triangle similarity. Alright, so now to set it up. Well, looks like the 4 feet goes over the 3 feet, or 30 feet. Then the 6 foot goes over the x. So this would be 4x. And the reason why I'm color coding these, I had somebody that wasn't really paying attention, which, imagine that, and then all of a sudden they ask a question like, how do I get these numbers? So that's why. Alright, so we have x equals 180 by 4. Alright, so this would be 45 feet. Alright, now that's it for the lesson. Y'all have 3 problems, only 3. It could have been more, but I know that's why we're going to have our practice time tomorrow. 3 problems to work on, and we're doing the same thing. So look at your postulates and stuff, your side angle, all that kind of things. Okay? Alright. So don't forget, hit like, subscribe to the bell. Good stuff, good things. Roll Tide.